What is going on, guys? Welcome back. In this video today, we're going to learn how to implement durable AI agents in Python using an open source platform and package called Agentspan. What do I mean by durable? Durable basically means that if the process crashes or if there is some human step needed that can take for days maybe until a human gives actual approval, that the agent can keep the state and it can keep running smoothly without having to restart just because of a crash or because of a delayed approval by human. And while we can use Agentspan to implement the entire thing, we can also use LangGraph, so existing code basically without changing it, and just run it on top of Agentspan to get the same effects. This is going to be super interesting today, so if you like this video, let me know by hitting a like button and subscribing. But now, let us get right into it. Alright, so as always, I like to get started right away. We're going to open up a terminal and navigate to a working directory of our choice. In my case, that's going to be the tutorial directory. And in here now, you can create a new project, either by just writing a Python file, or if you're using a special package manager, like in my case, UV, you can initialize a project. So I'm going to do UV init. If you're not using UV, you don't have to do that. You can just use Python to run stuff, and you can use pip or pip3 install to install packages. Since I'm using UV, I'm going to do UV init and UV add to install the packages. Now, if you also want to use UV, you can install it either using the pip package manager or the cargo package manager, because it's a Rust-based Python package manager, but you don't have to care about UV if you don't want to. I'm just going to use it here. So, of course, since we're covering Agentspan in this video today, we're going to have to install it. So either run pip or pip3 install, or you can say UV add Agentspan. That is the package that we're going to use here to build durable AI agents in this video today. Now, what is Agentspan? It's an open source platform / framework / SDK for durable AI agents. Now, to be transparent here, they're sponsoring this video today, but as I mentioned, it's completely open source, it's free, it's self-hostable, you don't have to pay for anything. You can go to the GitHub, download the entire code base. This is not a paid product, it's an open source platform that you can use to develop durable AI agents. And the idea of a durable AI agent, maybe I can briefly use my fancy touchscreen that I have here to sketch something very basic. What do we have is we have an agent, let's say, and the agent has to go through a certain workflow. So there might be a step 1, there might be a step 2, then maybe it splits into sub-working steps. So we could have something like 3A, and then maybe 3B, and then maybe 3C. It's not going to be the most beautiful graph here. And then maybe we have some aggregation step, and then we have step 4, which is the end. So again, not the most beautiful graph here, but the basic idea is now, if the agent now goes and executes this flow, let's say we get here and now these have to be executed. And then maybe one of them already finishes and the other two are still working. Now, if this agent crashes here, so if there is a crash in the program that executes the agent stuff, the tool use and everything, basically what happens in a normal setup is everything's lost, and the next time you start it, everything starts from scratch. So you have to go again through the entire process. Now, with a durable agent, what happens is that we decouple the agent logic and the execution workflow. So the idea is we have whatever the agent does, the actual tool execution is happening on the program side, but the entire thing here is saved as a state on a server. This is what Agentspan basically does. So all of this is stored on a server. And if the program now crashes, what happens is this state is still on the server. We can reconnect to the state and just continue working through everything here without having to start all over again, because we basically have the entire information on the server. Same thing can be done with human in the loop. You don't have to crash the program. Maybe there is a step that requires human in the loop approval. A human has to say, okay, let's do this. Otherwise, the program cannot proceed. And maybe this human is on a vacation right now, needs 3 weeks to respond. And what we want to happen, if there's a long process before that approval step, we don't want to lose everything just because the human takes days, weeks, or maybe even months to respond. We want to keep track of the state. We want to store the state, and then the human can approve, and we can continue from there, so we can keep track of the entire thing. We don't have to start from scratch just because the human takes too long to approve. So long story short, that is what Agentspan does. You can also see how they describe it here in the docs. Basically, this is what most frameworks do. We have the process, the agent loop, we call the LLM, execute a tool, call the LLM again until we're done. And here, basically, we have the Agentspan server where we outsource the tool work, we delegate the tool work, and the execution happens here. And this decouples the entire thing. So the server, it also has a monitoring tool that we're going to take a look at. keeps track of everything and makes it durable. So without going too much now into theoretical detail land, we're going to start by building a working version of a crash and resume mechanism. So I want to show you how we can build with Agentspan a program, an agent workflow, where the agent can crash and then continue where it left off instead of starting from scratch. After that, we're also going to do a human in the loop example. And finally, then I'm going to show you a LangGraph example, so an already working workflow in LangGraph, and we're going to see how easy it is to put it on top of Agentspan without changing any of the logic, without changing any of the code, but still having the benefits of Agentspan. So as I said in the introduction, we can use Agentspan in two different ways. We can build the entire thing with Agentspan, or we can combine it with something like LangGraph without changing any of the existing logic. The first two examples are going to be in Agentspan. The third one is going to be LangGraph with Agentspan. So let's open up a main py file here, and we're going to start with some imports. The first one is import OS. Why do we import OS? Because we need to keep track of the execution ID of the workflow that we want to resume. So sometimes you might want to actually start the script and start a new process, a new workflow, a new execution. Now, if the execution is interrupted, we are going to save a file with an ID of the execution, because we can have multiple that are interrupted. And the ID that we find in this file will be the one that we continue with, that we resume, so to say. However, we need to check if it exists, and this is what we're going to use OS for. Also, we're going to import time, because we're going to delay the execution just so we have time to interrupt the workflow. This is just artificially doing some work here so that we have time to intercept and say crash the script. And we're going to use random to do some random work and random delays as well. Now, the actual important imports here are from Agentspan. So from agentspan.agents, we're going to import the agent class, the tool decorator, the start function, the agent runtime, and the agent handle. And before we talk about all this, let us just define two basic tools. So we're going to have one tool that is just going to process stuff in chunks. So this is going to literally be a tool. It takes some ID in, produces some random output, and that's it. The second tool will be for aggregating these results. So we have the results from multiple chunks. We're going to aggregate them and then give a final response. This is, as I said, a mock example. So this is just to have something that takes time and gives us something so that we can simulate an actual workflow. Of course, you can do this with any real example that you want. So add tool def analyze chunk. We're going to pass a chunk ID, which is an integer. And this is going to return a dictionary. And of course, since this is a tool, we need to provide a docstring, a simple function that processes a data chunk and returns metrics. And what we're going to do actually here is we're going to sleep for a random amount of time, rand int anything between 3 and 8 seconds, let's say. And then we're going to also return a dictionary, and a dictionary will contain information about this chunk. So on the one hand, of course, the chunk ID itself that was passed here to this function. Then we're going to say processed equals true. This is just a mock object. You can do whatever you want, actually. And we're going to have metrics, and metrics is going to be another dictionary, which will contain metrics and numbers. So basically count, let's say, and then random, rand int, anything between 5 and 8. I don't know. Just make something up, whatever. So that's going to be a mock function that takes some time and returns some data. And the second tool will take multiple outputs of this function, of this tool call, and will aggregate it. So it's going to be tool def aggregate results. The input here is going to be chunk results. Or actually, let's just call it results. And that's going to be a list of dictionaries. And the result here is also going to be a dictionary. Now for this, we don't need a delay. I'm just going to say here results is equal to results or empty list. Now, very important side fact here for those of you who don't know, you don't want to use a list and empty list here as a default parameter because it's initialized once at definition time and can lead to all sorts of problems. So anyone who tells you that you can do something like equals and then empty list doesn't know Python. That's just a little caveat. So we do this like this. So just give me an empty list if there is no input, and then we're going to return the aggregated result, which is going to be just the sum of the count. So it's going to be total count, and it's going to be sum of a list comprehension, which is going to be x metrics and then count. So just for the individual object, and this is going to be for x in results. And then maybe we can add one more field just so we have something else here. summary, and we can say analysis complete, whatever, just so the LLM knows that this is now done. And of course, don't forget the docstring, because otherwise it's gonna not allow me to do that. Aggregates metrics from all chunks into a final report. There you go. So these are the two tools that our agent will have. And as you see, the analyze chunk takes some time, so we can interrupt it. So now let's define the actual agent. This basically works like in most other agentic frameworks as well. You just have an agent class, you specify the model, you specify the tools. So first of all, we give it a name. Let's say this is going to be our data analysis agent. Then the model is going to be equal to OpenAI. Here we use the slash notation. It always depends on the framework. Sometimes you use slash, sometimes you use colon. In this case, OpenAI GPT-4o is going to allow us to use GPT-4o. And then the tools are going to be a list of tools, which are going to be the functions passed as entities. So analyze chunk and aggregate results like this without parentheses because we're not calling them. And then we provide instructions, which is basically the system prompt. Now, to not waste any time here, I copy pasted this. What we're going to say is analyze data in chunks using analyze chunk, then aggregate them with aggregate results, process each chunk sequentially, so we have more time in this case. After calling analyze chunk for every chunk, call aggregate results and pass the list of all chunk results as the results argument, report progress as you go. That is what our agent is made for. And now what we're going to do is we're going to see how we can make this durable. So of course, if you just have a basic agent like this, you can run it, it can crash, it will just lose the state and that's it. What we want to do instead is we want to make sure that interrupted executions are going to be resumed. So there is going to be a file maybe called interrupted execution ID, let's call it this. And if this file exists, we need to proceed otherwise, or to resume. And if this file does not exist, we're going to start from scratch. So we need to actually check here, first of all, if os.path.exists, and we're going to negate this. So we're going to say if not os.path exists. And then we're going to choose a file name. I'm going to say here interrupted execution ID. So if this path does not exist, this file is not here. What we're going to do is we're going to just start the process with Agentspan. So we're going to have a handle, we're going to use the runtime, and we're going to write down the current execution ID. So the idea is we're going to always create this file, interrupted execution ID, to make sure that our ID is stored somewhere. Now, of course, you don't have to do that with a file. You can also have an admin dashboard in your application. You can find any way to handle these execution IDs. The only thing that you need to understand is that you have an execution ID when you start an execution, and you need to have this execution ID if you want to resume that execution. Whether you stored it in a file, in a database, in the admin dashboard, in a JSON file, doesn't matter. You just need to have a way to get this ID back into the program so it knows what to resume. But in our case, this file does not exist. So what we're going to do here is we're going to say handle is equal to, and then we're going to use the start function. So the start function returns an agent handle. We don't have to use the agent handle class for this. The start function actually does that. And here we're going to pass our agent. And the start function basically instructs the agent to do something. So it's like prompting the agent. Let's say analyze the chunks with IDs 1, 2, and 3. Now in this case, of course, since we have a mock application, all that's going to happen is it's going to call this tool with 1, 2, 3, and it's going to return some random values. But in reality, this would be a workflow. This would be some work that has to be done. Now, in order to get now from this handle the execution ID, we first need to get the status. So I can say here status is equal to handle get status. So this gives us the status object. Now I can also print the status if I want to. So I can go here and say status, actually not dot something, just status is going to print the status. We can maybe add a string here. This is going to tell us running or failed or completed or something like this. In this case, running, of course. And from this status object, we can also get the execution ID. So I can say here execution ID is going to be equal to status dot execution ID. So this is the thing, this is the identifier of what we're doing right now. If this crashes, I need to have this ID so I can resume. So what I'm going to do is I'm going to export it into the interrupted execution ID file. With open interrupted execution ID in writing mode, SF, I'm going to say f write execution ID. So now we have it stored. Now, maybe you're asking, okay, why do we call this interrupted if it's not interrupted? The idea is that if it's not interrupted, we're going to delete it at the end. So if it's not deleted, there was an interruption. That's the idea. So we call it like this and we create it beforehand, and then we go into the actual work. Now, to not have to write if else a lot of times, we're just going to always, regardless of whether the file existed in the first place or we just created it, we're going to load the ID from the file directly. So I'm going to say here with agent runtime, as runtime, we're going to load the ID from the file. So with open interrupted execution ID in reading mode as f, and it's going to be execution ID is equal to f.read. So that's either going to be the ID that existed in the first place, or if there was no execution to be resumed, it's going to be the ID that was just created. Now, next what we want to do is we want to serve using the runtime. So we're going to say runtime serve, and we're going to serve the agent. And we're going to say blocking is equal to false. And now basically we need to get the handle back in case that it was not started here. For example, we need to get the handle, the agent handle, based on the ID, based on the execution ID. So I'm going to say here handle is equal to agent handle. And I'm going to pass execution ID is execution ID. So what happens now is we have the runtime, we have the handle, and the handle is going to reattach itself to the execution ID, either to the new one that was just created here or to the old one that is now being resumed. And of course, we need to also pass the runtime here. Now, one thing that's important in case you're playing around with this and wondering why it doesn't work in a different script, it's important that when you do this, when you actually serve the agent and everything, when you reattach the handle, so to say, that you do have the tools here. So you need to have the same agent here. Otherwise, it's not going to recognize that you can reattach the agent or the handle here to the process. So if we want to, we can also print the status again. So I can use the print statement. I can say status is equal to handle get status again. And then to get the results, I can say result is equal to handle dot stream and then get result. And if I want to, I can then say print results to actually see the final result. Actually, I should not use plural here. It's just result. Result is equal to handle stream get result. Result print result is going to just print the final output of the execution. And then this is important. We need to remove with OS remove. We need to remove the interrupted execution ID because otherwise it's going to try to continue next time. And finally, we can print completed. All right, so if I didn't make any stupid mistakes here, this should work and show us how such a crash and resume mechanism works. So I can say UV run main py in my case. If you're not using UV, you say Python main py. So I'm running this now, and this is going to either start, in your case now, an Agentspan server. In my case, this server already exists. And I can go to localhost 6767, and then you can see here the different execution IDs that are running. Now, in this case, I'm not even interrupting it. I can just take a look at it and see what's happening here. So I can monitor here in the web UI that we started with a prompt, then we had the LLM call. The LLM call decided to do analyze chunk 1, then another LLM call, analyze chunk 2, another LLM call, and then if I refresh here, it's going to be another one, and then the aggregate, and then we have the final result. And also in our command line here, we can see agent output. The analysis of chunks with IDs 1, 2, and 3 has been completed. Aggregated result, total count 20, probably correct. We had random numbers, so we cannot really check. We had 4 tool calls. And this happened now without interruption. So this didn't really show a crash and resume mechanism, but we can see that there is no interrupted ID that we can continue with here. So if I run this again, it's going to start a new execution, as you can see here. Now, what I can do is I can take a look at this execution. Maybe it does a tool call already. And now I'm going to Control-C to crash the script. So the script is now dead. Now, the execution is not dead. It still has the status running. So right now, there was the prompt, there was the LLM call. The LLM call decided to call the tool analyze chunk, and I interrupted it. I crashed the script basically. What you see now is I have an interrupted execution ID. We can also take a look at that. Interrupted execution ID, there you go. And this thing is now stored on the server. Now, one thing that's important, if you want to run the Agentspan server, it's going to automatically run when you start a script if it's not running. Otherwise, you can also say UV run Agentspan server start. You can also say server stop. The important thing is you need to run a command called UV run, or just Agentspan if you're using pip, Agentspan, and then doctor. This is going to tell you if you have an API key exported. Now, I started the server already in a different instance, so I had an API key. If you don't have an API key, you're going to see here, no AI providers configured. So what you want to do is you want to say export open AI, API key, for example, or Anthropic or Gemini or whatever, and then the API key. And this is going to have the API key in the environment, and then you can run Agentspan doctor again. It's going to tell you everything works, and then you want to start the server because that is going to then allow the server to actually use the OpenAI API. Otherwise, of course, you don't have an API key. How do you want to send requests to the models? So what you can see here is it's stuck, nothing is happening, it's still running, it's not failed, it isn't stopped or anything. And now I can go and say UV run main again. This is going to pick it up again. There you go. You can see analyze chunk now successfully executed. Then it goes to the next LLM call. And of course I can keep interrupting, by the way. I can crash it again. The ID is still here. I can refresh here. Now one tool call was successful. Another tool call was successful. The third one is now pending. We're waiting for it. Nothing's happening. I can go back and say UV run main py, reattach, and it's going to continue with this workflow. It's not starting a new one. If we go to the agent executions, there's no new execution here. We're continuing this one. I can reload again, and you can see there is a final output, and I get it here in the command line. So I didn't have to rerun any tool calls. We just continued where we left off by reattaching to the execution. All right, so this was one use case, crash and resume. Let's move on to the second one, which is human in the loop, but delayed. So maybe a human in the loop is required. We need to have some human approval, but it takes some time for the human to respond. Maybe 3 days, maybe 5 days, maybe a month, whatever. It needs to be stored somewhere, and the human has to at some point say go, and everything that happened up until this point needs to still be there, needs to still be saved somewhere, and the state needs to be kept so we can continue where we left off. We don't have to start again. Especially if the process before the human approval is quite intense and maybe takes a lot of time and resources, it doesn't make sense to repeat it only when the human is there again to approve the process. So what we're going to do is we're going to go back into main py. We're going to change this example a little bit. I'm going to get rid of these two tools because we're going to have different ones now. And to keep it simple, I'm going to just copy paste the new tools. It's nothing new here, so you're not going to be confused. It's basically just a couple of tools. The only thing that's new, and I'm going to talk about this here, is the approval required here. So these are 3 tools, simple as before. We have get order. All that happens here is you get some string, that's the order ID, returns a dictionary. Look up an order ID. And then just a basic random number times 100, which is going to be the amount. So that's going to be a number between 0 and 100, basically. And it gives us the order ID, status delivered. Get customer gives us just a customer ID, always Mike and email mike@mail.com. And then there is a function called process refund, a tool called process refund. The idea is I can specify an order ID and an amount, which is a float, and we need a space here, and it's going to issue a refund. In this case, of course, that just means returning a dictionary that says that the refund was actually processed. But in reality, this would be a refund process, the actual refund process. And this one, we add here the parameter approval required. So basically this means that this is not going to run without a human saying yes or no. Also, the agent here is going to be the refund agent, and it has different instructions, and it has these 3 tools. Everything else is the same, nothing new here. We just have a bunch of tools and an agent. So the instructions here are you handle refund requests, look up the order, look up the customer, call process refund. It will pause for human approval automatically. That is what the agent does. This is the job of the agent. And now we need to see, or now we're going to see how to use Agentspan to delay this human approval without causing any issues. So we can basically keep the code that we had before. I'm just going to rename this because I want it to be now current execution ID because it doesn't have to be interrupted necessarily. The prompt is also going to be a different one. Refund, or let's say issue a refund for order O_123 of customer, let's say C_951. Then I'm going to get the status. The status, we don't need to print it necessarily, will give me an execution ID, and I can write this to the file called current execution ID. So just like this, same as before. That is the mechanism that allows us to store the ID and to then continue where we left off. And now we're going to use this current execution ID to continue. Now we're going to also do down here in the runtime the same thing that we did before. We're going to load this ID, the current execution ID. We're going to serve. We're going to have the handle But this time now the status is going to be in a loop. So what we want to do is we want to do a polling mechanism. So I'm going to say basically keep going every X seconds, ask for the current status. And if the status is waiting, ask for human approval. And maybe we also want to have a certain number of time maximum to try this. So for placeholder in range 60, let's say 60 times, we want to do time sleep 2. So we have some time in between, and we want to get the current status of this execution of this handle. And I can say then print status dot status. And we basically now have two scenarios. Let's get rid of all this. The two scenarios are the status is waiting or the status is complete. So I'm going to say if status dot is waiting, then we need human approval. So I'm going to do pass, and down here I'm going to say if status dot is complete, then we need to do something else. So if the status is waiting, in this case now my human approval mechanism will not be a fancy admin dashboard. It will not be some webhook or something. It will just be a simple user input. Do you want to approve this, yes or no, in the command line? Of course, you have to adapt this to your use case. So if you're using this in a web application, there might be some webhook that you want to implement here, or some webhook handler, or you want to have some admin dashboard button or something. But in this case, I'm just going to say choice is equal to input. Do you want to approve? And then we can use actually an F string here. The following is going to be status.pending tool. There's going to be a tool that's pending. It's going to require approval. We can give that approval or reject. So I can say if the choice dot lower is equal to yes. So if I type in yes, we're going to approve. And we do that by saying handle.approve. So that is going to allow the tool to actually be executed. Otherwise, we're going to reject. So I'm going to say handle reject, and I can provide a reason, whatever reason. I'm not going to provide one here in this case. So handle reject, whatever reason, and then we need to remove the file. So remove the current execution ID, because if you reject it, it's over. We don't have to do anything. Just delete the current execution ID and break out of the loop. Now, if we approve, we're going to continue, and the status is going to be complete in the next iteration. So in this case, we're going to print completed with a colon here, and then status dot output, then result here as the key. And then the usual thing, which is result is equal to handle dot stream, not stop, stream, get result, and then result dot print result, and then always remove and the current execution ID, and also break out of the loop. So that's basically it. Now we have this human in the loop process. We can take a look at this. I can say UV run main py. This runs everything. In my dashboard here, I should be seeing that there's a refund agent. What did it do? It ran the LM inference. It got the tool call get customer, get order. It got everything it needed. And now it will try probably here to run the tool call that requires human intervention. So I should already see it here in the command line. Do you want to approve? And then I just have this dictionary here, so we don't have proper formatting. You're also not seeing everything because my camera is blocking it. It's not that important, but you can see here that there's a tool call and that it requires human approval. So I can type yes or I can type no. Maybe let me just briefly move my camera here so you can see that. This is what it looks like. And now I can type yes. In this case, it's going to approve it. If I type no, it's going to be rejected. So yes, in this case, responded to execution, running. The next thing is completed. And then you can see the refund has been successfully processed. Now, what I can do as well is I can just crash the process. So there will be some human approval at some point. We're going to wait for it to happen. So it's going to do what it does. Then it wants my approval. I can just Control-C, break out of the process. So this is going to be new execution now. And we can see that human approval is required here. So it still needs to happen. We do have a current execution ID here. And if I now run the main py file again, we're going to see that it's going to reattach to the approval. There you go. I can still approve or not. I can go with yes again. And this is going to then finish this execution. And I get the answer. All right, so this is all nice, but let's say I don't actually want to use Agentspan as my agentic framework. I want to use LangGraph. I don't want to rewrite everything. I don't want to learn a new framework. I don't want to rewrite my entire code base. I just want to use what I already have. For example, I could have this LangGraph example here, which is basically, again, analyze chunk and aggregate results. It works perfectly fine. I don't need to do anything. this is my setup. I would like to benefit from Agentspan, but I don't want to rewrite anything. This is also possible. So what we can do here is, first of all, let me install LangGraph and also LangChain with OpenAI. And then what I also have here is .env file. This .env file basically just contains OpenAI API key is equal to the OpenAI API key. And I also loaded in the example here using load.env. So we just have the OpenAI API key here. And if I run this, if I run the LG example, this is going to be a basic LangGraph example. It will run on its own. We're not going to go into specifics of LangGraph here today, but that's going to have the same effect. It's just going to run. But of course, it doesn't have the durability. It doesn't have this crash resistance. It will not be able to keep the state if I interrupt it. It will always start a new execution. Now, the cool thing is I can easily attach this to Agentspan by just wrapping the runtime around it. Now, this is not going to make it durable, but we can at least see what's happening in Agentspan, and then we don't need too many more steps to make this durable. So all we have to do here is we need to say from Agentspan .agents import agent runtime, this one here, and then we can just say with agent runtime as runtime. And then we need to just slightly change the way this is written. We don't say app invoke, we say actually runtime.run. We pass only the app, not the invoke. And we use a comma here, but the rest stays the same. So we still pass the same dictionary here with messages and the human message in here, and that is going to be the result. So runtime run, app, then the same message as before. And we also need to access the result in a different way. You can basically say print result.output and then result. So this is enough to wrap Agentspan around it. So I can say run LG example, and it's going to use Agentspan to do that. So I can take a look at it. You can see this is running here. You can also see that this is in LangGraph. So this is not our own custom agent here. This is our LangGraph workflow. But of course, it doesn't give us durability. We don't have a resume mechanism here yet. We just see what's happening. We can analyze the workflow here. We can also crash it, but it's not going to continue. It's not going to allow us to just restart this and it's going to work. So we need to do some extra work here. And the cool thing is we don't have to touch anything here about the LangGraph code. We can keep the state graph. We can keep all the classes states. We can keep the functions, the nodes, the tools. Everything can stay as it is. We just have to alter this part. We have to extend it a little bit, and everything else can stay the same. So what I'm going to do first is I'm going to say runtime deploy and the app here as a parameter. Then I'm going to say runtime.serve the app. And I'm going to say again, blocking equals false. And then we're going to do our check whether a file exists or not. So if os.path. Actually, I don't have US imported, so OS imported. So we need to say import OS. If OS path exists, let's call this one interrupted execution ID underscore LG for LangGraph. And of course, we want to negate this if this does not exist. Then we're going to say handle is equal to runtime.start. And we're going to start the app with the prompt that we have down below. So actually, we're going to get rid of all this here. And we're going to pass this dictionary. So a dictionary with messages, with a list of messages. And then we need to close this dictionary again and also close the function call. So I think that should be fine with the parentheses. There you go. And after this is going to now start the inference, basically. After this, what we want to do is we want to get, again, the ID, the execution ID, and we want to write it into this interrupted execution ID file. So I'm going to say with open and then interrupted execution ID LG in writing mode, SF. And we can also access it directly here from the handle. So I can say f.write. We're going to write handle.execution ID. So we don't actually need to go to the status for this. We can just say handle execution ID, write it into this file, persist it, so to say, and maybe we want to also print a message, start it, and the handle execution ID, just so we can track what's happening here in this LangGraph graph. But the interesting part happens in the else branch, because here we do actually have this file. So I'm going to say with open this file again. So interrupted execution ID LG. In reading mode, SF, the execution ID, and I need colon here, the execution ID is going to be equal to f.read. And then I'm going to say handle is equal to agent handle, and we pass again the execution ID and the runtime. And we can also have a status message here, which is going to be resumed. Now, then we can say result is equal to, and another way to wait for the result is to use the join function. So we don't have to necessarily say stream and get result. We can also say join, just a different way to do this. And then the result is the same though. We can say result dot print result, and very important, OS remove our interrupted execution ID, LG. We don't need that. And we can also print completed one more time. So you can see the logic is basically the same. I used some different functions here, join to show you that this also works, also execution ID directly from the handle, but essentially it's the same idea. So we just have this workflow here. Everything here is the same as it was before, just a LangGraph workflow, and we just wrap this in a runtime, and we just have this logic here of crash and resume, same way that we had it before. So I can write this UV run LG example. Let's just wait without interrupting first. This starts a new graph here. When we refresh, we can see that this actually splits into 3 parallel tool calls. We can just wait for this to happen. We don't have to do anything. I'm just going to let it play out, and then we're going to interrupt it and see how we can proceed. There you go. So this worked without interruption as it worked before. Then let's go to the agent. Let's rerun this. This should now spawn a new execution. And once it gets to the tool call, I'm just going to crash it here, keyboard interrupt. So now it's stuck right here with these tool calls. So we can see it's loading. It's not going to do anything. It's not going to continue working because our worker is actually dead. So it doesn't do anything. But I can now go and continue. Of course, it doesn't work because I need to import the agent handle as well. So import the agent handle. But since it was exported correctly, this should now work. Anyways, so this now reconnects to this execution. Hopefully, yeah, there you go. No new execution happened. So this is reconnecting to this one. Tool calls are happening. We just have to wait. And at some point, we're going to get the final result here without having to rerun everything from the beginning. There you go. So as you can see, it's super easy to build durable AI agents using Agentspan directly. So either using it as an agentic framework, or also you can take an existing LangGraph workflow, for example, and wrap Agentspan around it. And then you have the same possibilities of doing these crash resume or human in the loop workflows and mechanisms. So make sure to check them out. As I said, they're open source. You will find a link to them in the description down below. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, of course, don't forget to check out Agentspan, the sponsor of this video. You're always helping out the channel if you interact with the sponsors. As I said, they're open source. They allow you to build durable AI agents. You will find a link to them in the description down below. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you for watching, see you in the next video, and bye.